is our press conference for today. We made a lot of progress with the FDI specification, and that's what you're going to see here today. So we have Mr. Achim Labenstein from ABB, Hans-Georg Kunkmuller from Siemens, Mr. Stephen Mitschke from the Fieldbus Foundation, and we're going to give you a brief update as to where we're at with the FDI specification, but also, and perhaps more importantly, with the developer tools that we're offering, and that's what you're going to see from Stephen Mitschke as a brief demonstration of these developer tools that we have available. So I won't take up any more of your time. I know we're really pressed for time, so we'll go ahead and get started.
Thank you, Larry. I will not use the microphone. So welcome to our FDI press conference. Welcome especially to the guests from the press. Who from the press does know what FDI means? This is not very promising so far. FDI stands for Foreign Direct Investment. No, I'm kidding. I'm kidding. FDI stands for Field Device Integration. And we do this press conference intentionally because we know that especially in the United States, the education about this is not yet so much developed. So FDI is Field Device Integration. You maybe remember the war in the beginning of 2000 between EDT, FDT, DTMs, and various variants of EDT, how to integrate a field device into a DCS system. Because this was not solvable technology-wise, a group of industry members and also all main foundations came together in 2009 and founded the FDI LLC. FDI means Field Device Integration, and this is today a major milestone which we want to show you what we have reached in this process for field device integration. Therefore, we have made 4 major bullet points today on the table: release of the FDI specification, the usability style guide, the demonstration of the development tools, which are a major part of FDI, and also the beta version. And to show you also how important this meeting also is for our foundations, I maybe introduce also shortly our main members of this FDI LLC. So we have here Ted Masters, from the head of HCF, and we have Rich Timoney, head of Fieldbus Foundation. We have Carsten Schneider from Profibus, it's here. We have Tom Burke, the most important part, from OPC, and also there are around many members. Hope I did not forget anybody, because Glenn Schultz from FTT unfortunately could not make it today. So is here, and also many members of our board are today represent. So if you have afterwards individual questions to Yokogawa, Emerson, Siemens, Aspil, ABB, these people are also around that you can ask them how serious they are about FDI. So this is basically our presentation. Again, this FDI thing was created to merge the best of EDTL. EDTL is a text language, has to be integrated by the DCS system, and then the DCS system understands the messages from the device. And FTT. FTT is more a software-based integration method with higher capabilities in terms of visualization and program interface. Both of them have the advantages and disadvantages, as you see here, and we have created now a nice new, so-called new technology, which is of course not absolutely new, because it combines the best of both worlds, from EDT as well as from FTT. And the core part of it is called the FDI package. And what is this in detail? A little bit more technical. Achim Labenstein, who is a technical director of this FDI LLC, he will explain you now also in details where we are and what we can do. And we also have prepared a nice demonstration from Stephen Mitschke. He is the technical head of Fieldbus Foundation. He shows us how easy it is to create out of an EDD an FDI package. What are the status of the tools? Yeah, we are, I think, Achim, you take on the next
Okay.
step.
Thank you. So FDI is about two things, technology-wise. One is a specification, and the specification is going to become an IEC standard. And the other part of FDI is to develop what we call tools and components that make it easier for device vendors and also for host vendors to implement FDI into their tools or systems and devices. You see here a project timeline, and you see already a lot of green tick marks. This is the schedule for the IEC specification. So we, as usual, we started with the new work pattern proposal, and we reached currently the status of the committee draft for vote. This committee draft for vote review is ongoing, so from our point of view, it's done. We will receive the comments, I think, around mid of March. Then we will incorporate the comments from the committee draft for vote. And the goal is to have an international standard at the end of this year, if we fulfill this schedule, and the probability is very high that we fulfill it. I said we also develop software, host components, and the integrated development environment. You will see more during this presentation about the software. In our software development, we have reached also here a major milestone. We are now ready with a beta release, which will be provided to the members of the foundations. Hans-Georg has named the Profibus organization, Fieldbus Foundation, and also the HART Communication Foundation. But I will tell you more about that. So, the specifications are in the IEC review process. This is one thing. But to make interested companies aware and give them the possibility to learn about FDI, we have published already a first final draft version of FDI on our FDI website. This has been done back in November last year. So a FDI specification is now available on the FDI Corporation website. Everybody can download it, can use it to do prototype development or start to get familiar with FDI. We'll talk about the integrated development environment later here, and Steve Mitschke will show it. We have today released the so-called FDI style guide. This is a complementary document to the specifications. It will help device vendors to develop a common look and feel for their device packages. So a device package from a certain vendor will in a host system always look the same, independent of who has developed it. This is a very strong end user requirement from end users like the chemical or the oil and gas industry to have common look and feel across devices, and therefore we provided this FDI usability style guide, which is also now available. Now coming to the software we develop, because it's one thing to develop a specification, it's another thing to implement things, and therefore we have developed standard software components that help to improve interoperability across systems, because we mix devices from one vendor with systems from another vendor, and therefore we have standard components for the system vendors that ensure that a device package always can be executed in the system. And those components are called UI engine, the user interface engine, and the EDD engine. And the EDD engine is a EDD interpreter. You may have heard about this. There are interpreters today in the market. The speciality here is with one interpreter that can be used across protocols, which makes it easier, again, for the device vendors to do their device packages and for the system vendors to implement FDI, because they don't have to care anymore for different Fieldbus protocols. They have just one software. This battery is empty.
Nope.
Those FDI host components can be used in two different kind of hosts. Hans-Georg has talked a little bit about FDT. So we have pure native FDI hosts, which the host components are used in, and we have FDT-based FDI hosts. So the existing FDT system shall be backward compatible to FDI, and therefore FDI shall also run on an FDT host system. And the same components we have developed can be used in native FDI systems, also in FDT-based FDI systems. Now, some words about the integrated development environment. Stephen Mitschke will show it here. The development environment helps device vendors to develop their device packages for their devices. And it supports several steps of doing device packages. Editing a device description, converting the device description into a binary format, we call it tokenizing, and package the device description with a so-called UIP, a software application that is an optional feature of FDI. And then there is a reference host that is part of the IDE. The reference host is the runtime environment for device packages. So a developer can test his device package also on this IDE. And this IDE, we would like to show to you now. You see here a setup with the IDE software. And you see 3 devices connected. A HART device from Amazon, a Profibus device from Siemens, and an FF device from ABB. And I think you see this the first time here in the US, that with the same EDD interpreter, we can run 3 different protocols and devices from those different vendors. I think this is a first time this is presented here in the US. We have done it also in Europe back in November, but this is a premiere here for this location. And Stephen will show now the workflow to create a device package, editing, tokenizing package, and run it on the host, and have a live communication between the tool and the devices.
All right, thanks, Akam. Brief introduction, my name is Stephen Mitschke. I've been with the Fieldbus Foundation for nearing 18 years. My job is to manage the products and services at the organization, testing, training. I've been highly involved in device description technologies and the work we've done through the collaboration of, at first, the EDDL cooperation team, and now FDI for about 11 years. And you should feel lucky today. You actually, in this room, get to witness a historical first, something that has never been done, to the best of my knowledge, and that's to see a Fieldbus Foundation guy show you a demo of a HART and a Profibus device. First time ever, so round of applause for that excitement. So, let me set some expectations here. I'm an engineer. I like to talk about tools and all the fun stuff like that. The tools I'm going to show you today have a lot more details I'm going to gloss over. They're developer focused. They're to make it easier for device suppliers to rapidly develop FDI device packages for their field devices. But what I want to focus on, as I sort of show off the tools, it's not so much to show you all the cool and neat features we can do from a development side, but show you just how FDI has really made some nice advances in terms of quality and usability, bringing together technologies from both EDD and FDT into a common framework. So, some ground rules. These are beta tools. They are focused for developers. This is not a real system. I'm not going to show you nice, pretty screens that you'd see from Wonderware or PRM or Delta V or all that stuff. These are developer-oriented focused tools, so we need to set that. And as beta tools, they have a lot of debugging and all that stuff information. There's not performance-optimized tools. So any of the speed that you see here is certainly no way indicative of final release tools. This is pre-release tools. So without that said, What I will show you is really sort of an industry first, as Aka mentioned, a common development environment and a common runtime environment that integrates really the major communication networks for the process automation industry. Fieldbus, Profibus PA, and the Foundation Fieldbus. No doubt you've seen other systems today. They've integrated these protocols in various different ways, integrating different pieces of software, whether it's SDC, DD services, or own interpreters. That's been done today, but this is the first time when you actually have real common software, protocol independent software, interacting with those three major communication networks. Some of the nice things that we'll see, FDI from the ground up was built to be scalable. We knew we have to, for the basic devices that don't need all the complexity, keep it simple. But simultaneously, for those devices that need a degree of sophistication, whether it's your positioners, which can do all these nice valve signatures for quality, or radar guide array radars, where you have complex tanks, where you need graphical representation to often visualize the data, we scale appropriately based on the needs of the supplier. And ultimately, that scaling becomes important because, frankly, quality. Simple things, keeping it simple for the simple devices, means the guy's going to do it right the first time. He's going to manage it in-house. He's not going to outsource it to some company to spend $100,000 developing a software. He eventually gets back, he runs it, and oh my gosh, he has a problem with it. He's got to go spend another bitch of money. He has no knowledge. For the basic devices, keep it simple. They can keep it in-house. And I'll actually show you some of the simplicity of EDDL, but when necessary, provide the flexibility for moving forward. All right, as Vaka mentioned, 3 basic devices here from Siemens, the Systram pressure transmitter, running Profibus PA, going down to a PA-DP coupler, going through a softening US interface, USB into said machine. Simultaneously, have the ABB temperature device going to an H1 segment through the device using a PC card. And finally, I have a 3051C 4 to 20 milliamp device with HART, and that is going through a MacTech modem to USB into the PC. It's all real stuff. Our stuff right now in this version is online software, so the only way I can show you stuff is actually going online with these real devices. All right, so the editing environment that we have within FDI is built on the open source platform called Eclipse. This basically provides the area where people sit there and write their Ds. And when I say Ds, what do I mean by DDs? Well, no, don't tell ABB, but this is actual source code of their software. Typically, they like that's intellectual property and all that, but don't tell anyone.
Well,
so, just a snip of it. You didn't hear that. But I just want to show you just how easy EDDL is, and there you go. Mary, see, so devices inherently have variables or objects, some complex records, and so on. But generally, you got the thing that describes the device as a bunch of variables. What's a process variable, PV, or some diagnostic variable, so on. And the way you describe it is pretty simple. You give it a variable, you give it a name, you give it some help information, class information, data type. In this particular case, it has this bunch of enumeration, so instead of you having to manually remember that 1 means PV1 or 2 means sensor 2, you get nice text strings which can be multilingual and all that stuff. So this is literally a portion of code that's created to do that EDD. Now EDD sort of provides you 3 basic things, right? It provides you the definition of the parameters themselves. Then it provides relationship information. So like you have unit codes that gets transferred or interrelationship between parameters. And finally, context-oriented menus on how parameters can be organized. And I'll be showing you that online here in a little bit. So FDI brings in that best world of FDI. FDI brings in the best worlds of those EDDs. But in the end, the real magic that happens with FDI is the device package. This is the new thing. If there's one new bit of vocabulary, one new term we got to learn, because we're engineers, we like to create acronyms and TLAs, those 3 letters. We love creating new words. But if there's only one word you have to ever understand about FDI, it's a device package, because this is the key deliverable. I'll show you what one looks like. This is the key driver that will be provided by the device supplier to the system to integrate the device in an FDI environment. And this device package not only contains the DDs and these special plugins, a variety of basic information, whether it's manufacturing, contact information, all this goes along to the, describing the device types and so on. But one of the nice things about this packaging technology is it allows us to incorporate other documents as well. Because when it comes down to managing asset life cycles, you need more than the DD. You need plugins. What about certification documents, product documents? Where's the darn manual? How many times you got to, where I got to go to a website? Can't go to a website right now because it's blocked from the internet. So how do I get that? The nice thing about FDI, from a usability standpoint, we now incorporate all these different disparate artifacts into a single file called the FDI package. So this is a basic tool. Developers use this tool to create packages. They fill out a bunch of forms. There's a lot of automation to make it life easier for the device supplier. When it's all said and done, it actually shows up as a device package. So you want to see what a device package looks like? Well, not terribly excited. Those are 4 device packages, 4 files. They have a common file extension, FDIX. There's also a common naming convention that incorporates the manufacturer name and revision details. Now, the nice thing about this is oftentimes it's useful to kind of compare, well, how do we do it today? Well, whether it's Fieldbus or Profibus, an example, when you think of DD files, and with Fieldbus and HART, you see file names like that. Well, what's that? And by the way, the other devices got the same file names, just a different directory structure. Or HART, or if you're talking about Profibus PA, typically you have a variety of source files. Now, in the end, Fieldbus Foundation, we put this in a zip file, we package it up, or vendors will package up separately. Gone are those disparate ways of collecting all these individual files, or CFF files, or FHX, or not those files, the GSD files and so on. One file to rule them all, right? If I want to borrow that particular analogy, with apologies on
Don't
that.
apologize.
So this is, what gets more exciting is we actually use some of these files. So what we have on here, again, is we developed a basic environment so that you can write your DDs, you can build up your catalog information, you can build up your plugins, but now you actually want to test it. You want to show it, because without the proper tools to implement it, either you got to go buy every system in the world, which that costs money, effort, resources to keep that updated, or here we've decided to actually spend a good amount of investment to create common reference host for displaying those particular packages. So, being a Fieldbus guy, I will pick on the Fieldbus device first. Don't worry, I'll get to the HART device in time. So, I will pick on the AV device. So, we picked the package. Now, this is just a sample implementation. It's not going to look terribly exciting here, but there's a couple important things that happen behind the ground that I think it's worth mentioning. Number one, FDI in the specification has a fairly well-defined lifecycle policy. Upgrades, updates. Is this a side-by-side installation, or is this replacing and so on? The specification allows the device developer to provide those hints, and the host system then can provide that, integrate that as necessary. So whether we're updating existing device type or which versions of packages are compatible with which device firmware, all well-defined from day one, built in the specification. Number two, security is also an important part in our industry. And with FDI packages, we want to make sure that those packages, A, were developed by the person we thought developed them, and B, arrived to us uncorrupted. And so during that process, there's certificates which are assigned by the original manufacturer, validated to make sure that the device package was developed by the person that was supposed to develop it, and importantly also was not tampered with or corrupted. So once it passes the deployment scheme, we hear it open up. So some of the basic catalog information which can be provided in the package I told you You know, things like classification, all that stuff. Some of the low end, you know, the mnemonics on the manufacturer and all that so on. But you know, beyond that, you have we have those, like before, attachments. So here within this package, I inserted during the build time product manuals and certifications. So if I'm loading this package in my system, which is now persisted in my FDI server, and later on I need a catalog for this particular transmitter, it's certainly available to me right from that FDI package. So, all right. But, only so exciting. Let's go online to the device. So this is now actually loading the package. It's creating an online session with the actual field device itself. It'll take a little bit of time to load. But I want to show you just briefly some of the details that come from that EDD perspective. And it should be, there it goes. 5 more minutes, almost there. I'm just getting to the pretty stuff. So my screens are a little bit tight here. I'll try to push some stuff over. These development tools are, I'll just swing some stuff over. So the data here, which is being read from a field device, you see some of the images. You see some of the typical things that you see from EDD. I know it's the screen's a little bit tight here. But in this particular case, we're reading the transducer Bach value, which is roughly about 22 degrees C. So here in this device, we've simulated some different some numbers. These are live field values, which are coming from the device itself. But when I talked about organizing the EDD in different menus, you know, device settings, diagnostics, and these are 3 common entry points going to be found in all FDI packages. So that's an FF device. Well, what about a HART device? Let me show you another example here. A HART device has got a little bit more fancier graphics, so bear with me as I load that one real quick. So launch that, import the package. Select this. Come on. PC's not the fastest either. Deploy that.
You got 3 minutes, Steve.
I hear you. Oh, fine. You guys worry. You know what? I'm going to grab one more while I'm at it. Make it a little bit more fast. I'm also going to grab one more device. It's a this particular package is a test package associated with the HART device because it implements a plugin. And so, again, we go back to the concepts. Now, one of the things to understand about plugins is, the nice thing about FDI is that they're targeted to specific platforms. FDI allows a variety of different types of contexts for plugins, whether they're targeted to a desktop or workstation. And the nice thing is the client picks the one that's appropriate to its application. This time, this particular device has a plugin. This is where we've gone from the EDDL world to the more complex world of programming technologies a la FDT. All right. So, launching this one up. Bear with me. All right. So let's go take a look at some of the process variables. As it renders the UI, I'll try to shift some stuff around to see as it comes in. We see some pictures, there we go. Some of the gauges, some of the datas are updated. I apologize, the screen's a little bit tiny here. Let me see if I can get you just a little bit more room. Yep, I know. So, you know, we get this, so everything you see up, this is all EDD driven. And so, you know, to put that gauge on that few lines of code, you get a nice pretty gauge, which is nice because the gauge that comes from the other device package is going to look the same. We have diagnostics. I'll show you if I can, actually, hold on. Let's do this real quick. 2 more things. So we have another rich diagnostics. Bring this menu up here. Again, all purely EDD driven, coming from the EDD. reading information live from the device, like tags, serial numbers, and all this such. Materials of construction. There's trending graphs and all that stuff typically you need. But when you need a little bit extra power, you have plugins. Now, if you'll notice, you know, we have buttons there which allow us to invoke different windows and so on. So here, let's, my plugin is not sexy. Let's be honest with you, it's not a sexy plugin. It's a developer-oriented plugin. But there's an important thing to note here. Could you tell the difference? This is a plugin. See, in FDI, plugins are like mini apps. Your basic device integration works with EDD, and then when you need that extra power, you run a plugin. But the nice thing is with the plugin, which read the ambient properties of the system and all that, you know, the look and feel sort of maintains throughout the system. Consider Windows 3.1. Remember the look and feel? And then Windows 95, 90, it's changed over time. All became system dependent. EDL, system independent. As your technology evolves, it can match your system without having to go back and re-engineer all your tools. And this is some of the key parts that make up FDI. So, you know, there's a lot more to show, but I know my time is up. So, you know, the big thing to take away, you made history. You saw a Fieldbus guy show you a HART device and a Profibus device along with a Fieldbus device. Industry first use of common tools. This is truly a common integrated development. That's going to make quicker to market. It's going to make interoperability as we have more and more mature products to take advantage of those particular items. And finally, it really provides us with a good platform to move forward. So exciting stuff I'm working with. There's my quick 10+ minute demo, and now I have to turn it back over to Akam to finalize our press.
Yeah. Thank you very much, Stephen. Stephen summarized already, but I'd like to add on what you should take with you as a message. FDI specifications are available on the FDI website, and those tools you have seen here are available for anybody who is interested to test a beta version. And this is the message you should convey. If somebody is interested in using such beta version of the tools, he can get it through Fieldbus Foundation, through HCF, or through the Profibus International Organization. Thank you very much. And now we open to questions.
Yes.
Walt Boyes from the Industrial Automation Insider. We've seen some revelations in the last few weeks about the ability of hackers to get into wired HART systems through the instrument. What will FDI do to make it more difficult to do that?
Stephen has explained already some things. We have foreseen provisions in the specifications so that we can always ensure that a device package is authenticized. It is from a certain vendor. So this is by built-in certificates. And of course, host vendors will have to ensure that such things as were described in this hack cannot happen. I think this was more an implementation thing than a technology or specifications, as far as my understanding goes.
Yeah, just that. I mean, certainly we put a lot of provisions in there to try to maintain independence amongst things. So, you know, we've done a lot of work on the packaging and certificates to really verify that what's being delivered is there. But on the system side, our tools and so on, analyzing those for potential interfaces, because, you know, the typical way you do that is exploit buffers and unintended messages like the one that happened most recently. So that's where we've been spending a lot of time to try to make sure there's a good amount of independence and those buffers, amongst other things, are checked. So that's been part of our process and will continue to be a part of our process as we expect this software to be used by manufacturers long term. Yes?
Sorry, we've run out of time, so I'll bring
Thank you.
questions offline at this point. Thank you, gentlemen.